All right. Finding the horizontal or oblique asymptote. You cannot have both in a rational function. Okay. You can have neither one or the other, but never both. Got it? Show 5.5 continued. So we have, when you're looking for the oblique or horizontal asymptote, it is basically based off of your leading term. So your leading term has your coefficient, the leading coefficient, the highest exponent, and it's whether the degree is greater than or less than. So the degree of your numerator and the degree of your denominator. If the degree of your numerator is less than the degree of your denominator, then that lets you know that you're going to have a horizontal asymptote and it's at y = 0. So if it's so you have numerator. I don't know why it's n and I don't like using that. Why they use n and d. So if the degree of your numerator is less than the degree of your denominator, you have a horizontal asymptote and it's y = 0. Okay. And again, it's their degrees that you're comparing. Okay. If the degree of the numerator equals the degree of the denominator, that means you have a horizontal asymptote, which is y equals, and y equals your leading coefficients divided. So the leading coefficient in the numerator divided by the leading coefficient in the denominator. If the degree of the numerator equals the degree of the denominator, you have a horizontal asymptote. The horizontal asymptote is y equals the leading coefficient in the numerator divided by the leading coefficient in the denominator.
Wait, so you said, okay, so if the degree.
Read the sentence.
Yeah, if the degree of the denominator.
That's definitely not what it said.
Oh, wait, if the I'm gonna just.
Are you done? All right. So we're going to continue. If the degree of the numerator is 1 more than the degree of the denominator, then it has an oblique asymptote. And in order to find the asymptote, you would have to do division. So if the numerator degree equals the denominator plus 1, then you have to do long division. Oh. All right. Are you ready to see some examples? So we have n is greater. Let me go back. We have n is less than, and if n is less than, then there is a horizontal asymptote at y = 0. If the numerator equals the denominator degree, then we have y equals leading coefficients divided by leading coefficients. If the numerator equals the denominator plus 1, then we perform long division and we find our oblique asymptote. Now, what happens here? If the numerator is greater than or equal to the denominator degree plus 2, there are no horizontal or oblique asymptotes. Okay, what does it say? No horizontal. So basically, if n is greater than d plus 2, then there are no horizontal or oblique asymptotes. Okay, if before you even get started, you end up factoring and reducing and you end up with a linear, then they do not have any asymptotes. You more than likely just have holes in your graph. All right, ready? So here we go. We have 3x to the 4th minus 2x cubed minus x divided by x to the 6 plus 4x squared plus 8. So we're going to look at the degree. The degree of the numerator is what? 4. The degree of the denominator is 6. Do we see that?
Yeah.
So this case, we have our numerator is less than our denominator. Agreed? So if the numerator is less than the denominator, that means that you're at y equals 0. Horizontal asymptote is at y equals 0. How do we feel about the first example? Questions, comments, concerns? We identified the degree. We set up an inequality. Then we made our conclusion. All right, can I keep going? All right. Next example. We have 2x to the third plus 2x squared plus 2 divided by x squared plus x plus 1. What is the degree of the numerator? What is the degree of the denominator? So we have numerator is greater than denominator plus 1. What does that mean? Long division. It means long division has to take place. Okay, so that means long division has to take place. When you set up long division, remember the numerator goes inside. And if a term is missing, you must put in a 0. So we have 2x cubed plus 3x squared plus 0x plus 2. Because I was missing my linear term. Do we see that? Yes.
So, you know how a numerator
What was your, I don't get your question or your,
It only talks about the degree, it's not the entire.
yeah, it's just strictly what the degree is. That's the rule for knowing what type of inequality. Oh, I put greater than. I see what you're saying. I didn't mean to do that. What were we talking about?
Wait, why
They're equal. Sorry. The numerator equals the denominator plus 1. Lo siento. I didn't mean to write that symbol. Thank you. So we have x squared plus x plus 1. Okay. When you're doing long division, what do? You divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. So I'm going to ask myself, 2x cubed divided by x squared is what? 2x. Agreed? So we divide, then we multiply. 2x times x squared is 2x cubed. 2x times x is 2x squared. 2x times 1 is 2x. And then we subtract. And we're left with x squared minus 2x. And then we bring down. And we repeat the process, right? So we're going to divide. X squared divided by x squared is what? 1. So 2x plus 1 is where we're at now. After we divide, we multiply. 1 times all 3 of these terms is just going to be themselves, right? 1 times x squared is x squared. 1 times x is x. 1 times 1 is 1. Then we subtract. And we're left with negative 3x plus 1. Your horizontal, your oblique asymptote is this. So our oblique asymptote is y equals 2x plus 1. They're your remainder. So this is just a remainder.
So I know not to keep going if I can.
If you can't divide again, then you stop. Can I divide 3x evenly into x squared? Nope.
It's not possible.
No,
Like at all.
no,
It's not like some secret
no,
iron.
no. All right, I'm going to erase it. Okay. So because of that, we do the division, which we did, right? And as a result, we end up with this. And the piece that is our asymptote is the 2x plus 1.
Wait, do you know that? What do we do with that?
This right here,
Yeah, how do we get all that stuff?
this is just showing you with your remainder. So this is our asymptote. And this is the remainder. Asymptote, remainder. Asymptote, remainder. All right, so what does that look as far as the graph? It means as x goes to negative infinity or as x goes to positive infinity, what's happening is that it's gradually approaching 0, right? It's trying to get there. And so as x goes to negative infinity or x goes to positive infinity, on the other end, it has this boundary line at this asymptote, which is 2x plus 1. So when we graph and see it, we can see our limit, see our function, and that's why you have this asymptote. So that's in the conclusion, an oblique asymptote at y equals 2x plus 1. And again, this happens when the numerator equals the denominator plus 1. The degree of the numerator equals the degree of the denominator plus 1. Questions about example 6? Do we vaguely remember long division from previous times in our lives?
Yeah.
So when you graph it, this is what it would look like. You can see how the function, it's trying to get close to the red line, but it's going to actually never touch the red line. And you remember how we said in the beginning that a function can cross oblique and horizontal? Here's an example of it being crossed at the oblique. All right, let's talk about this guy. Example 7, determining whether it's horizontal or oblique asymptote. So we have 9x squared minus x plus 1 divided by 3x squared minus 2. What is the degree of the numerator? 2. What is the degree of the denominator? And so numerator equals denominator. What does that mean? Glad you asked. Good job. It means that we have a horizontal asymptote. And to find that horizontal asymptote, it's y equals your leading coefficient of your numerator divided by the leading coefficient of your denominator. So what is the leading coefficient of my numerator? 9. What is the leading coefficient of my denominator? So y equals 3. There's my horizontal asymptote. Okay, so if the degree of the numerator equals the degree of the denominator, all we have to focus on is the leading coefficients. How does that sound? Doable? Yeah. It was easy. I'll take it. All right. So there it is, all pretty for you. Okay. Oh. So you're saying I wasted my time?
Yeah, when it looks like that.
You just told
It
me.
doesn't look real. It doesn't make sense to my brain.
Okay, well, good thing I write too, huh?
Yeah, so maybe you do it for us.
To see why the horizontal asymptote equals the ratio of the leading coefficient, we're gonna look at the end behaviors, okay? So as the graph y equals 9x squared and the denominator approximately, which is 3x squared, what do they look like graphically? Well, graphically, they're gonna be similar. The only thing that's gonna change really is the major part where you're multiplying. And because that's all that's gonna happen, it's gonna just keep going. I thought I put a graph here. I didn't, I lied to you. I thought we were gonna look at it graphically, but I forgot the graph. But you could just see that their shapes are similar because they're odd functions with even functions. So they're basically the same shape. One is just a little more narrow than the other. And so as they expand, what's happening out here? Okay. Where am I at? Next one, example 8. What we got here? What's the degree of the numerator? It's 5. What's the degree of the denominator? 3. What is their relationship? Numerator is greater than the denominator plus 2. So what does that mean? What'd you say? I can't hear you. No,
Wait, isn't it? numerator equals to-
it's greater. It's greater than or equal to.
Oh,
It means that there isn't one at all. So if the numerator is greater than or equal to d plus 2, that means that there is not a horizontal asymptote or an oblique asymptote.
so no horizontal or.
No horizontal or oblique. This is probably the easiest of them all. Writing no is too much.
Yeah.
Okay. All right.
Wait, how would we answer that as a question?
No horizontal. Mhm. All right. How do we feel? Pretty good?
Yeah.
All right. If you want, this is just a further explanation what happens to the graph. Here's an example of what it looks like. So as you can see, they're just kind of moving around each other. They're not interfered or affected. Sorry. I wonder what happened to my other graph. Who knows? But anyways, at least this graph's here. Questions, comments? So there's no boundary lines. There's nothing stopping it. There's nothing interfering with it. So therefore, the graph is chillaxing. And that is it. That is it for 5.